wanted to tell you that before I started recording. That's right. That's why I did. All right, so this is not y by itself. There's not anything right in front of the y. But again, that side of the equation has other stuff on it. It's got the 2x. So when we say all by itself, this is what all by itself looks like. The only thing on that side of the equal sign is just the letter y. That's it. And actually, that is, we're fine with there not being an x on the other side. Y is all by itself. That is slope-intercept form. And we would use the yellow sheet. So that's how we tell. That's the answer to number 1. So now let's say it is in the format of number 1. How do we pull the slope out? How do we know which number in there is the slope?
So the slope has to be the number.
Always.
If the number has something in front of it, like a negative sign or a plus sign, you have to include that with it.
Perfect, 100% correct. So again, that is up on the board over there where it says y equals mx plus b and it points to the m. The number in front of the x is the slope. Always. If I made this equation, I can't really do it the way it is. Let's move it. If I made that equation into this, so the x term isn't on the left anymore, which is what we normally see. The x term, then some number. The number over here is still the slope. And just like Jaheim said, we have got to include that negative sign. So the slope for that would be net, and m stands for the slope. The slope for that would be -2. So don't, because, and again, here's why so many people did not, and I haven't finished grading this class yet, you're the last class. The reason so many people did poorly on the quiz and on the graphing is because of the graphing. If you don't write that negative sign there, there's no partial credit. That's wrong. It is wrong, wrong, wrong. I can't give you partial credit for not being able to pull the slope out of an equation, or the y-intercept out of an equation, or being able to put the point. Let's say you do pull it out of the equation correctly, but then you put it on the wrong spot on the graph. I mean, there's no partial credit for missing any of those. You've got to be careful. Like the highest score so far on the quiz, and again, I haven't finished this class, but I've graded some of them. Highest score so far is a 91. This wasn't that bad a test. The people that did poorly, for the most part, a lot of silly mistakes, like not pulling the negative sign out, like going the wrong direction for the run or the rise. Even though you had it written right, you just didn't go the right direction. Or maybe you put the wrong number on top, the wrong number on bottom. Like, it was just silly stuff. You've got to be careful. It's not complex. It's not tremendously, like, what's the word? There's not a lot of calculations, we'll say that. But you got to follow all the steps. You can't skip steps. You can't get careless, because otherwise you'll make mistakes, and that's going to cost you. We have an exit ticket this Friday. It's going to be pretty similar. It's going to be all graphing. We're going to add one piece to the graphing. What's that? We're going to add one piece to the graphing that we've already been working on. Again, I don't think that piece is real difficult, but I'll tell you right now, some people are going to struggle with it because you're going to try to take shortcuts or just not maybe put as much effort into it as you should, which is what the last class did. All right, so here's the first thing we're going to do. This is a little bit of review. It's not going to be on the exit ticket, but it's something we didn't do very well on the quiz. No, not until I say, okay, we're getting to work on the worksheet. It said at my convenience, so it can't be that important. So. All right, so I'm asking you, so this is a bunch of different ordered pairs. I'm asking you, are these ordered, and I'm going to even put another one on there. Let's do this. Nope, I don't like that. There. So there's another one. I'm putting that one up there because I want to do one, give you an example, but I want you to still have the other ones that you can do. So I'm asking, are these ordered pairs solutions? Which is the same thing really as saying, are those ordered pairs on that line? Because we could graph this line, right? And if we graph that line, we could just check all of those ordered pairs. But let's say we didn't graph it. This is something we did not do well, and this is a very, not a big topic, but you will definitely see it on the EOC. No doubt there's going to be some kind of question similar to this on the EOC next year. So very popular type of question. If this ordered pair, I'm just looking at the first one right now. If that ordered pair is on the line, or if it's a solution to that equation, well, how would I know that? What do I need to do? How do I know if that ordered pair is a solution? The one in red right now. What do you think?
You put 3
I just plug it in the equation. If I take, because this is just an x value and a y value, right? Every ordered pair is just an x and a y. Even if it's in a table, it's still just an x and a y. If that ordered pair, 3, 7, is a solution, well, if I plug those values in for the variables, for the x and the y in the equation, it better make the left side equal the right side. That's the whole reason we started with the definition of an answer being it's the values that make the left side equal the right side. That's what an answer is. So if this is an answer, if this is a solution, it'll make the left side equal the right side. So I'm going to test that out, and this is what you're going to do for these, so make sure you're writing this down. You should have that equation written down, and you should at least have 3, 7 written down for right now, since I'm about to do that one. So I just say, all right, well, the math would be, here's the variable y. Well, I'm going to replace that with the value for y from that ordered pair. So I replace y with 7. The rest of the equation doesn't change, by the way, except for the y and the x. This is 2 times x. So that's 2 times x. Well, then I need to make it 2 times whatever the value of x is. Well, the value of x is 3 from that ordered pair. So I just replace the x with the 3. And then the plus 1 is still there. This 2 and this 1 should never just magically disappear. Last class, a bunch of people were somehow taking the 2 and the 1 out. Like, that's part of the equation. You can't just remove those. Now, we're going to do some math with them, and then they won't be there. But until we do math, they can't just disappear. So on this side, the left side, I have 7. There's no math to do on the left side. It's just going to stay 7. On the right side, though, I need to do the math. 2 times 3 is 6, plus 1. So I get to the end. I got one number on each side. You'll always get to the bottom and have a number on each side, because we got rid of all the variables, so we should just have a number on each side. Is that a true statement? 7 equals 7.
Yeah.
Of course that's true. 7 equals 7. 7 is the only number that equals 7. Any other number on this side, and then that would not be a true statement. If it is a true statement, so yes, that is true, 7 equals 7, then that is a solution. We've done something similar to this before. We just talked about one variable, now we're just doing other 2 variables. So that's a solution. So I would write, I mean, I put a check, but you could say, yeah, yes, that's a solution. If it's false at the end, you get 2 different numbers, then it's false, and you could write no, not a solution, or just no. So I want you to test those other 4, 0, 0, 0, 1, 1, 1, 1, 3. I'll walk around, see how you're doing. I'm going to do the attendance in focus real quick, though. Once I get done with that, I'll walk around, check a few. I probably won't check everybody, but I will check a few. Or I may get everybody. I don't know. Depends on how people are doing. How do I free? Oh, there we go. Yes, yeah, you're testing all of those points for that same equation, y equals 2x plus 1. So you're basically saying, are those points on that line that we could create from the y equals 2x plus 1? And we're going to do some graphing today, but as you hopefully know, we could graph that if we wanted to, since it's in slope-intercept form. Blah, blah, blah. Let's see, 6th period. Who are we missing? A lot of people. Egan, Jonathan, not here. Jonathan's not here, right? He must have left. Tarvis not here. He may show up. Who knows? Salazar, Keys, Nayland not here. All right, done with that. So, at the door. Did you just hear the door? No. Man, I thought I heard the door. Hearing things. I've always heard things actually. Oh, no. You should probably be scared. Yeah. I would be scared if people hear things. You never know what that is. You know what that is? You should look so understandable. That's normal hearing things. Not when the voices are telling you to do bad stuff. I literally just said, who knows, he may show up later. All right, so I was walking around. Let's see what we got. Oh my goodness gracious. You guys need to work faster. You're doing this stuff. Right answer. What's 2 times 4? Only one. I think you're plugging your X or Y in the wrong spots. Y is the second number, but it goes into the first. Very careful. A lot of people have been doing that today. Just plug in the first number in the first variable, second number in the second variable. Write our keys. Our keys didn't make that mistake. I see that. You're already up on my board right then. No, that's not going to be an issue. Right. So that means if it's not true, that means it's not on the line. Wait, what is 2? So if we get, which one is this? Oh, you're getting check. So far, so good. Super fast today. Good. So that one, which one is that one? Oh, this one over here. All right, good. Good. All right, so we're in good shape. I think we're doing okay on this. So if it's true, what's that mean? So we get down and it says true, what's that mean? What does it mean if it's false? What does false mean? What did I write up?
I figured you would.
If it's false, it's not a solution, which also means it's not a line. False means no, not a solution, not a line. True means, yeah, it's a solution and it's on the line. All right, make sure you write that note. Right, there you go. Good. Good, good, good. Good. So again, if you're right there, it's true. That means what? Correct. So again, if you're right there, you get that. It's true. Same number. That means it's on the line, or you could say it's a solution to the equation. Oh, you were on the yard. So you need to grab while I'm walking around. There's a graph that has 6 graphs on one page. That's all we want to do. That looks good. This is where you're setting that is. So what do we have on the left side of this? Always 0, right? 0 just goes straight down. This is plus.
switch your own. You don't use the paper for that. For what? If the Y is by itself, you use the yellow sheet. There's only one. The one from Gill. Either, I don't know, the yellow, the light yellow.
On this one?
I don't know.
On this one? Why is it on this one?
I don't know.
I don't think you have to mark it.
Because I just fixed mine.
And then if the Y is
Hard for me to
not
tell
by
which one you
itself,
got wrong or
you use
messed
the
up.
white sheet.
I see how I did it. I did it easy because it's such a simple.
Actually, go ahead, go real fast. Didn't do anything anyway, shouldn't I?
0,
I waited here for you to do something.
0.
I'm gonna go over these real quick. So pay attention, try to follow along. All right, so quickly, we're gonna do these together so that we can move on to the actual lesson. This is more of a review of what we didn't do very well on the quiz. So if you haven't taken the quiz, hopefully you're better at that now. So we already did the 3 and the 7. So I'm gonna move. Try that again. There we go. So we're gonna now work with the 0 and the 0. So what do I do? If I'm testing the point 0, 0, what do I do? Yeah, I'm replacing the variables. Again, variables are unknown numbers. If we think we know numbers, then we don't need the variables. So we're gonna replace.
Mr. Gill, which side is the Y, which side is the X?
Where it says
No,
Y.
like all the things.
Next question.
Mr. Gill, if Y is by itself, which sheet do you use?
Y is by itself. Which sheet do we use?
You use the yellow sheet.
Standard.
I mean,
Pink is
yeah,
equations,
you use the
that's
yellow
not
sheet.
gonna
You
Oh,
use
yellow.
the color.
Light yellow, the one that's on Kayla's desk, other Kayla's desk right there. So if I plug in those, I get that math. Because again, once I plug in numbers for the variables, I can do all the math now. There's no variables left. So I get that, and then I get down to there. That is not a true statement. 0 does not equal 1. I hope you know that. People, sometimes I ask that question and like kids staring at me like deer, if you know what that phrase means, deer in headlights. And like I have no idea what I'm talking about. 0 does not equal 1. That is false. False, false, false. So if it is a false statement, then that is not a solution, which means also it's not on the line. They mean the same thing. Not a solution means not on the line also. I'm going to show you something in a minute. I don't want to give it away too early because it's super special, cool. Not really. All right, next one. What do I do? Yeah, be careful about where you plug stuff in because a lot of people accidentally just put the first number where the Y is and the second number where the X is because that's the order they are. You got to make sure you put the Y where the Y is, the X where the X is. 0 is still that. So now I get 1 equals 1. Is that a true statement?
Yep.
Absolutely. 1 equals 1. Check. Yes. I'm just going to write yes from now on. So we just do that over and over again. Every time you're doing that, you're testing that particular ordered pair. I'm not going to continue to do it. I'm just going to tell you which ones were and which ones weren't. That was a no. That was a yes. We got 3 equaled 3 on the bottom. So those were your answers. There was another way to do that. What's the other way to do that? That's the line right there. You graph that line, it would look like that. 3, 7 was on the line, right? That's what we said. When we said it was a solution. If it's a solution, it better be on that line that I graphed.
Wait, how is 2 a solution?
This one?
Yeah.
That's the one I just did. 1 would be here, right? Because that's the Y.
Oh.
0, you made that 2, which it was supposed to be 0 plus 1. You had 2 plus 1. So again, 3, 7 is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, right on the line. This one was not a solution, 0, 0, and as you can see, 0, 0 is not on the line. This one was a solution, 0, 1. Well, I go from 0 to 1, that is right on the line. So again, saying it is a solution is the same thing as saying it's on the line if we graph the line. And every single point we test, we can check on that graph. Or really, we don't even need to. Let's do this. I'll bet you anything if we did 2 and 3, bet you that would be on, or would make the left side equal the right side. Because it's on the line. So if it's on the line, it has to make the left side equal the right side. I'm sorry, 1 and 3. Scratch that. Oh, we already did 1 and 3. What's another one then? Let me give you another one. So we did, 2 and 1, 2, 3, 4, 5. Well, that's not. Oh, here you go. Did somebody just tap on a desk or something?
Yeah.
Somebody must have tapped on a desk.
Oh, this desk.
Oh, that and it always comes from right. So maybe it's the desk. All right, so now I did 2 and 5. Again, 2 and 5 is on that line. If you look at where that point would be, it would be, well, I'll show you. 2, 5 is on that line. So it better make the left side equal the right side. So 2 times 2 plus 1 does make the left side equal the right side. So again, a solution is on the line, but it all keys around the side that the left side has to equal the right side because of that guy right there. So here's what we're moving into now. We've already done it a little bit. We're moving into inequalities with 2 variables. So we've done inequalities with 1 variable. If you remember, we solved out before and we had to shade a line left or right. We said open circle, closed circle, shade left or shade right. It's kind of the same thing, only now we have 2 unknown variables. So what I want you to do, I want you to plug in. So again, here's your equation. I want you to test 0, 0 again. Is 0, 0 a solution to that? Wasn't before. Same, and it's the same exact expression, sort of. We have y, 2x, and 1, but we changed the equal sign to less than now. That's all we changed. Didn't change any numbers. No variables. Yeah, let's do a couple of these and I'll show you. So what did you get on both sides?
0, 1. Extra. I haven't even started. Just taking the equal, bringing it into whatever sign.
For that one.
Yeah, I got too.
So we got the same numbers, right? That's what we got when we did equals. Nothing changed as far as the math goes.
No.
But
Yeah.
when we change the sign, that just changes our interpretation of what the answer is. Now we have a new rule. The new rule in this particular problem is that the left side has to be, I'm not going to write all of it, but has to be less than the right side. That's just the new rule instead of equal to. Now what's going to happen is not only does it change that one, every single one of these changes. Because now when we use 0 and 1, we plug in 0 and 1, we get 1 here. Is 1 less than 1? No. Now all of our solutions are flipped, basically. This is now not a solution, which means every single thing we did up there, that is, that isn't, that is, that isn't. But nothing changed really with the math we did, the process. We just interpreted the answer a little bit differently, right? Right, Luis? Yeah. Anyway, I like that. Good. So when we graph, it's actually somewhat similar. We're going to create the first 2 points the exact same way that we did. Hold on just a second. If you're waiting for the bathroom, you can have to. But then we have to do something a little different for the last part. And it's basically because we interpret the solution, like all the possible answers, a little differently. So first, write down what's in that including what's in green. For some reason, people think that they don't need to write the green because it's a different color, but it's inside that weird shape. So I want you to write all of that. I'm going to zoom in a little bit. Wherever you can get to it. It is something you will use for a while, though, not just today. So make sure you can get to it. You'll use it today, you'll use it next class, you'll use it on the exit ticket, and then after the exit ticket, it'll probably be on one big exit ticket. Everything inside, yep, that weird shape. I'm going to scroll down. It won't all quite fit on the screen, so I'll scroll down a little bit more in a minute so you can see the last stuff in green. You can probably figure it out. In like 30 seconds, I'll scroll down a little bit more and you can see the rest of it. I'm thinking this week's exit ticket will probably be like a fairly normal sized exit ticket, but we will do one bigger exit ticket at some point. So kind of more like a mini quiz, or again, mini quiz, big exit ticket, whatever you want to call it. It'll be worth more points. That'll have kind of a summary of a lot of stuff that we've done. So it'll probably be 2 pages instead of 1 page. Yeah, I'm sorry, go. I'm not sure. You got all of that already? When you come back, did you get the, like, there's something below this.
That's dashed.
Did you take a guess at what that was? And did you know the symbols?
Solid, no line underneath dashed.
Here's the rest of it. You didn't figure it out already. So when you're done, just kind of put your pencil down. Sorry. When you're done. We're kind of wrapping it up. Right on the back of your notebook.
Yeah,
Or are you doodling?
no, I'm drawing it back.
Oh, okay. That's not this, though, right?
Huh?
Is that this?
Yeah.
It is.
It's easy to get to.
I'm just think that's funny that you didn't. Hope you don't change notebooks before the next quiz. All right, so I'm going to go over what this means pretty quickly because we're about to practice it. The first step is a very summarized version of a long process, but it's a process we've done. We did it all last week and the week before that. It says graph the first 2 points. Well, there's 2 ways that we graph the first 2 points. One's a yellow sheet, one's that white sheet. One slope-intercept form, which is yellow sheet, one standard form, which is white sheet. So behind number 1 is really where most of the work is. Again, we struggled with that on the quiz, so you need to practice that today, because Thursday's quiz is going to be really based on that. This isn't going to be worth tons of points. It will be worth some points, but this is still the main part of what we're doing, graphing the first 2 points. From there, figuring out number 2 is easy. You just look at the symbol. Like when you do the problem, kind of like I think we said in the other one, we said at the beginning of a problem, you could just look at the symbol and say whether it was an open circle or a closed circle when we did that other lesson on inequalities. You could just look at the symbol here and say, oh, well, that's going to be a solid line because it's got the equal sign before you even get started. So that part's easy, especially when you have your notes. This part, number 2, shading the third part is a little tricky. So we'll go over how to do that. So look at the sheets that you got. And I will let you choose the one that I do.
First.
I'm gonna do one. You want me to do the first one? Tyler spoke up. Everybody good with that? Oh, we're gonna have to do a vote.
Two.
All right, by show of hands, raise your hand if you want number one. One. You said number one. You don't want number one now?
No, I know it's a fraction of the other one. I'm scared.
Oh, all right. So he changed his own mind. All right. Well, then it's definitely two. Then only Emily wanted one. I think the fractions are easier, but you guys always think they're hard for some reason.
Oh, don't even have to put it all over the fraction.
Yeah, because you don't even have to do that second step. But it does. I will say it does have a negative in it, which makes part of what we're going to do a little trickier. All right. So when we go to graph a line from an equation, what's the first question we ask ourselves?
What's the slope and what's
What's
the
the
y?
line is up?
How do we know
it's
that the
the
slope
y
and
by
line is up?
itself.
It's the one.
First, you got to ask yourself, is y by itself? If the y is by itself, then you can move into slope and y-intercept. I kind of already gave you a hint that this was slope and y-intercept by doing that, though. So yes, y is all by itself, right there. If y is all by itself, then we are in slope-intercept form, and we need to pull out the slope and the y-intercept. So you can go ahead and do that real quick if you want. Just write the y and the b. Leave some room below the m and the equal sign so that although actually we don't need to change this into a fraction. All right, so what is, Lauren, what is the slope for this? Oh, 1/3. There you go.
Negative.
No.
Ah,
Negative 1/3.
all right, call yourself. Don't forget, whatever is in front of the number, and it's the number before the x for the slope. Whatever is in front of that is the sign. And that's very important when we graph, because that determines the angle, or whatever you want to call it, of the line, whether it's sloping up or sloping down. All right, so go ahead, write your slope over here. If you haven't already done that, if you weren't sure, there's my slope. I'm going to go with Luis. What's my y-intercept? On number 2. It is 1. It's the only other number in there. Again, if you don't remember that is up there, it's up there. It says a little arrow pointing to the m, because that's the slope. A little arrow pointing to the b, because that's the y-intercept. The y-intercept is always the one that is just a number, not with a variable. So that's the y-intercept. It is the y-intercept, though, so it's going to go on the y-axis. Still have some people making that mistake. So now that we've done that, we can use the yellow sheet. You should have the yellow sheet out, unless you just absolutely have this down pat, because you're about to be doing a bunch of graphing. So on the yellow sheet, we can now go to step 1, which is underneath the gray rectangle. Lazar, I feel like you're pretty loud. What's step 1 say?
Put a point on the y-intercept.
That's it, really. That's all you need. If the rest of that confuses you, scratch out the rest of it. You should have already scratched out for number 1. There was a little part in parentheses that says this, and I said just get rid of this. So it looks like that in that first step. I said just scratch that out. So if you haven't scratched that out, hopefully you have, because I've done that several times, you can just scratch all of that out. So literally all you need is that first sentence. Put a point on the y-intercept. You want to scratch everything else out, scratch it all out. Take a minute. All right, so if I need to put a point on the y-intercept, that goes on the y-axis, the vertical up and down number line. So I just go to the +1. Again, make sure you're putting it on the correct number, the positive number if it's positive, negative number if it's negative. There's no partial credit for writing it down wrong. So if you didn't write that negative, immediately you're wrong. If you didn't put it on the negative, if it is negative, then you're wrong. It's killed people on the quiz. Killed even people that were actually pretty good at it. Like, I know they get it. a silly mistake is 5 points, just like that. So you make 2 or 3 silly mistakes on the graphs, you're already down to a middle or low B. And then from that, you still got all the equations and everything else left. All right, so now we need a second point. There's our first point on the y-intercept. What does step 2 say, Tyler? You're pretty loud.
So I just read the first sentence.
Is that all we need?
Let me.
You tell me.
I'm gonna say the whole thing. If the slope is not a fraction already, then change it to a fraction. To change a integer, how do you say that word?
Integer means it's not a fraction, basically. So, yeah,
to a
integer.
fraction. So we do have a fraction, so we have to do that to change it to a.
What?
Put 1 over the number.
No, put the number
It's
over
already
1.
a fraction, so just skip to step 3, it says.
So that's what I was just gonna say. If you haven't written this yet, next to number 2, either left or right, wherever you have room, we said you could just write in if you already have a fraction, or if the slope is already a fraction. But you could look, if you pulled it out already, you just look right there. Is the slope already a fraction? Skip to 3. And this one is already a fraction, so we could skip to 3 for this problem. Now, if it's not, which not most of these, some of them are not, that's when you have to put the number over a 1, not under it, because some people are putting the 1 on top. So for example, if our slope would have just been -3, not negative, oh, I don't want to do that. That's going to be confusing. Here, I'll do a whole new problem. Let's say this was our equation. Let's say that was our equation. Well, I'd pull out the slope, y-intercept. Now, and to do this, you don't have to, I mean, you're going to write it somewhere else probably in a minute anyway.
Put under it.
Like that.
Put it under it.
Always. Well, you put the number, what it says in there is says put the slope over 1.
That's confusing. So put.
Whatever, then, okay, again, I'm so glad we're having this conversation. If it's confusing, change it. If that doesn't mean to you, like when you see me do it, if the wording doesn't mean what I just did, change it. Make it your words. This is just a template. It's a guide. You need to make it your own. You need to make it into something you can understand. That's why I go through and do examples so that you can say, oh, well, what he's saying doesn't make sense with what he's doing, then you need to change it a little bit. So if it makes more sense to you to say, put it, whatever you just said, then change the wording for yourself. Scratch out what I have and put your own wording in. And that's for everything I give you. That's why I say sometimes I hate saying things and having you write it down, because then it doesn't make sense to you when you go back and read it. It needs to be your words, which is why we do examples, so that you can then put it in your own words. All right, so we're not doing that problem. So we already have a fraction, so we can move on to step 3. Kayla, what's step 3 say? Oh, I'm sorry. Kayla M. So yeah, we just did, well, we didn't do step 2, we skipped step 2. Yeah.
Write the slope formula, rise over on, and next to that, write the fraction you created in number 2 or the fraction that was in.
Yeah, so basically you're just taking whatever the slope is and you're writing it next to this, and it should already be a fraction because we should have already done step 2. Now, a lot of people skip this step, and it costs a lot of you points on the quiz. I mean, a lot of points on the quiz. Because you either got the wrong number on top and on bottom, or you went the wrong direction. Between this and this shouldn't have really been any mistakes, but yet we had tons of mistakes. Because people didn't write this and they didn't have this already on their paper, I'm guessing. All right, so I'm going to write that. What's important about that slope, though, that I need to do? Something that's not tricky, but we just need to remember to do this.
Always do the runners.
Well, let me just do this. So I just wrote that.
Oh, negative. Like, so technically, like when you like negative run, and it's like not negative run, negative rise.
Rise is the top number. That's what you know.
Yeah, and then
Rises go up.
You put a negative.
This negative needs to go with one of those two numbers.
yeah.
I always put it on the top number because when we have a number that's not a fraction, like a negative, like we just had -2, it's going to wind up being on the top because we're going to put it over 1. So if that's going to always be the top number in that situation, we might as well just always make this the negative number. So now we have a rise, which is positive, never a bad idea to kind of write that in. And we have a positive run, and then a negative rise. And if you have this stuff, this replaces step 4. Step 4 is just all about which direction to go for the run. Step 5 is all about which direction to go for the rise. You can just use that instead of step 4 and 5. Or if you like reading step 4 and 5, you can use that. So now I just need to say, okay, well, if I have a positive run, I count 3 to the right. I'm not done yet, though. I don't put a point there. I have a negative rise. Well, that tells me up here, negative rise, count down. So there's my second point.
All right.
But what about, what's the dash thing?
Whoa, let's get to that. We're on step 1 still. We're about to move to step. We're about to move to step 2 right now.
Okay.
As soon as I do this cool trick.
All right, please.
Oh, no, you're right. All right. That's just because I'm lazy and I'm old. Been down that one. All right. So you missed it. I know you missed it. That it's the coolest thing you probably ever saw in your life. Well, I mean that you would have seen it. So I'm gonna get rid of these hops. I think you understand what I did, but I'm gonna try to clean it up for the next step. Saeed thought we were cheering for him.
That's what I'm saying.
I thought y'all set me up.
He spoke up.
He got nervous. He got nervous. No, we would have tried to draw on something on you. We did that one time with my ex-girlfriend's son. Actually, I didn't do it. She did it. Mom of the year. She drew all over his face when he fell asleep. All right, so I have my 2 points. And if you remember, or you wrote it down, the first step was getting the 2 points. Now we do the second step, which is because we do need to draw a line in, but we need to figure out, is that going to be a solid or a dashed line?
That one's gonna be dash.
So everybody agree, solid or dashed line? Raise your hand if you think it's a solid line. Ooh, 1 brave soul. Raise your hand if you think it's a dashed line. 2 brave souls. You guys may want to look again.
Y'all
I know a question. I know what you mean by dash.
It's solid.
That's solid because the lines.
Solid because.
Wait, is it? Wait,
Solid,
what?
that's solid.
Yeah, it's
Oh,
solid.
it's solid. I thought I missed
Everybody
that.
just went with Sarah because Sarah knows what she's doing. We'll just go with
No, I
Sarah.
forgot.
2 brave souls said, I don't know. That's not what I'm looking
I
at.
thought it was switched.
Yeah, be careful.
Solid.
Again, very good example of just be careful.
You're welcome. I'm so brave for y'all.
See, she
No,
did
I
that on
wrote that.
purpose
I wrote
just to
that
show
one.
you guys that you have to be careful.
Because I'm just so nice to you guys.
I know. So it is it is a line. There is this little guy underneath.
Y'all are-
That little guy says make it a solid line. So I'm going to make it a solid line.
Bro, I put it solid for one of them.
All right,
I
so
remembered it once.
now we have step 2 done. We made a solid line. Step 2 is easy. You better never miss step 2. At least get some points. Even if you do everything wrong in the graph, I'll give you some points if you just did a dash line when it's supposed to be dash.
What's the difference? Like,
What is dash line?
like, what does it look like?
Yeah.
What does it look like?
Like, just like, yeah, when you like dash something. Oh, like that.
Oh, okay.
Yeah.
Just breaks in between it. Let me ask you this question. Here's
difference.
Wait,
Yeah.
wait, I think I know the difference.
what's the difference?
Is it because it's not
Is
the
it
line
breaking
means
between
all those
Because they're all connected.
Some are the answer. But some
Close.
of them are right, some of them are wrong.
Because they're all
What do you
together.
mean some of them? Explain that.
Like whatever is on the actual dash is a right answer, but whatever is not in the dash is the wrong answer.
No, not that. You're on the right track.
Well, I don't know if this is right or wrong, but I feel like it would be like something in between the dotted lines. So like if it's like.
Nope, nothing to do with in between the dot, because I could make this dash line into this dash line instead, and then erase some little sections of the other, still a dash line. Like I could erase them and put them in.
Opposite of whatever you want.
I could make it those dashed lines. I don't care how the dashes look, as long as I know it's dashed.
It's more clearer. It shows you how clear it is.
No, it's not gonna do that. Something about what does the line mean, we said when we did an equation. It is all the possible answers, right? But what happens when we have this? Let's say we got to the end. We said that's not a solution then, right? But the line still needs to be in the same spot. Well, that's where all the come from. So if I make a solid line, we're saying when I plug those points in, the left side will equal the right side for those points on the line. If this is not the symbol and it's that symbol, the points on the line will still make the left side and the right side have the same number. Well, no, it's a dashed line because now those points, even though they make the left side equal to the right side, that's not a solution anymore, right? Because 3 is not less than 3. So now the left and right side will always be the same. So this side would still be the same numbers, let's say. But the difference is this is a solution because of the equal. Here it's not a solution. That's why we make it dashed, because we're saying those points on the line are no longer a solution. The number is not less than, or the number is not greater than itself. Here it's less than or equal to, so we can say, yeah, this is a solution because, yeah, 3 is not less than 3, but it is equal to 3, and that's okay in this side. Do you understand?
Yeah, that's not what I meant though.
No, that wasn't what you were saying. Something in between. The points in between, the space in between means nothing. You're just saying those points on the line are not solutions. That's what you're saying, basically. Or they are if you make it solid.
Well, after they said everything, after something, I was going to say that, but then you started talking, so I got that.
Okay. Again, that's a very good conceptual question. I will probably ask at some point, not this Friday, since it's the first week of this lesson, but I'll say something to the effect of, I'll give you the graph and everything, and I'll write the dash, and I'll just give you a point and say, is this a solution?
Oh.
And you'll have to understand, well, in this case, it's not, because the left side is not, or the same number is not less than the same number. Or if it's this type of symbol, you'll say, yeah, it is a solution because I'm going to get the same number on both sides. And in this case, that is a solution because the little equals guy means I could have 3 be less than or equal to 3. That's, again, if you're not getting that, don't worry. It's not going to be a huge part of any quiz or test ever. What was your question?
Is that the answer?
Well, that is step 1 and 2. We've done step 1 and 2. We still got to do step 3, which is the shading part. So here's 2 notes you need to take. First note is the shaded region is always, every point in the shaded region is an answer. It's an answer to the inequality. An answer, a solution. Solution's a better word. Every point in the shaded region is a solution to the inequality. And I'll show you this in a minute. Inequality. Right here. Every point in the shaded region.
Yeah, how do you spell that word?
Which one? Region?
Yeah.
R-E-G-I-O-N, sorry. Every point in the, or you could say shaded area, whatever you want to call it. If you don't know what region means, you might want to change that to a word you know. So every point in the shaded area is a solution to the inequality.
Wait, change it. Say again?
What did you write?
I wrote you wrote. I wrote what you said.
But it might still be right. That's why I asked.
The shaded region is the answer to the inequality.
I don't love that one as much. I did change it. You must have written really fast because I changed it really fast. Every point in the if you know what that means, that's what I'm worried about. So change it then. So it just scratch it out, or I mean, write this also. Same. I mean, you can have both of them.
What's after solution?
They mean the same thing. So every point in the shaded area is a solution to the inequality. And a solution means it just makes the inequality true. If I plug that in, it's going to make the left side either greater than, less than, equal to, whatever, the right side, depending on what the symbol is. We're going to give some examples of that. So
Every point is generated as a solution
to the inequality. All right, so now here's the next thing you're writing. Hold on, because you need to hear this anyway. I did have some, but people have been using them since we have to have cups now. So I don't know that I have any left. I was thinking about buying some and just keeping water in here because that's a whole fiasco. All right, so now how am I going to phrase this? How about this? I'm changing it from what I did before. I'm trying to make it as simple but yet understandable and still correct as possible. Let's go with this. One side of the line is the solution side. The other side has no solutions. I don't know if that's even good either. This one's easier to just show visually than you. So for now, write that. One side is the solution side. Like, I'll explain what I mean in a second.
One side of the line is a solution.
The other side doesn't have any solutions. So I guess you could say it's the no solution side, but I didn't want to say that. I'm going to show you again up here kind of what I mean, and then we're going to finish graphing anyway. So this is what that means. If, let's say, this is the side, and I say, oh yeah, well I know this point right here is a solution. I know that one point is a solution. That means every single point on that side is a solution. Every one. If you know just one is a solution, every point on that side is a solution. Or the opposite is true. If you know one point on this side is not a solution, then no points are solutions. You can't have some solutions over here and some solutions over here. It's all or nothing. One side has solutions, one side doesn't. Can't mix and match and like say, yeah, some of these are, some of these are. Doesn't work that way. So let's test it out. Because right now, I'm just putting that point. So let's figure out. Somebody give me a ordered pair. That's going to be on the graph. What was it? 2 and 4.
8 and
So
16.
2 and 4 is right there.
8 and 16.
Nope, too late. Plus that's it on the graph. So that's the point that Kayla just said. She said 2 and 4. Well, I want to know, is that a solution? Is that an answer to this particular inequality? How would I know that? It's not on the line, clearly. The line's way down there, right? But it doesn't have to be with an inequality necessarily. What do I do?
I don't know how to say it, but
You
like
Plug
looking
it
at it.
in.
Yeah.
When we're trying to find out if it's an answer, you always plug it in, pretty much, if you have an equation. So this is my point. 2, 4 is what we said. I just plug those values in. This is an x, that's a y. Same kind of thing we did for the bell work? No, it wasn't bell work. It was right after that. So I would say, well, and be careful again, the 4 is the y, not the 2. I'm going to do it over here because that's going to get kind of cramped. So 4 is my y. Everything else besides the y and the x are the same. Negative 1/3 times this time the x is a 2. And then plus 1. So that's, I took out the variables, I plugged in the ordered pair. I just got to do the math. 4 less than or equal to 2 times negative 1/3 is negative 2/3. Now, I could continue to do math, but do you really need to? All I need to know is this true or false? Because I got 4 on this side is less than or equal to that. I'm hoping you can look at this and tell there's no way 4 is going to be less than, even if I added these together and made it a bigger number, 4 is still not less than that number. There's no way 4 is going to be less than that right side. If you do the math, it comes out to be 4 is less than or equal to 1/3. Negative 2/3 plus 1 is 1/3. So that point did not work, right? Didn't work. The left side is not less than or equal to, which was our symbol. Left side is not less than or equal to the right side. So that did not work. That means this side is not it's the no solution side. Which means this side is the solution side. You don't have to test one over here. Once you test one point, you're done.
Shade that side?
So we would shade the other side, exactly. So I'm going to use my fancy highlighter.
That's a beautiful highlight.
I love doing this part of this lesson. Wait till we get to this one lesson where we get to use 2 colors on one graph. Oh, so exciting. I know, it's fun. By the end of the week, everybody's going to want to color them. So, well, it gets tricky with the conceptual stuff, like the understanding stuff. So here's my next question. If I plug in the point 5, 1, is that going to make that a true statement? Still on number 2. So this statement, if I plug in the ordered pair 5, 1, is that going to make that a true statement? Is that going to work? Is that a solution?
No.
How'd you know? You didn't even do any math.
Yeah, I didn't have to.
I'm sorry, what was
Why? You didn't do any math. How do you know?
I was looking at the line on the graph.
So what about it?
5 is not on the shaded side.
That's all you do. You don't need to do any math. It's absolutely correct. All I do, if I give you an ordered pair and I say, is this a solution? Is that a solution? You don't need to do any math. You don't need to plug it in. You just look at that point. That point's right there, right? That's not in the shaded region. The shaded region is all the answers. And the line in this case, so the line and the shaded region. So yeah, that is not. Now, let's say we don't believe Mr. Gill, that one side's all the answers and one side's not. So we tested this. Maybe you're thinking, boy, I'm still not sure this is all answers. Let's test the point over here. I, by the way, always test 0, 0 when I do this process, because there's no math that's easier than multiplying by 0, adding 0, subtracting 0. I use 0, 0 every time. You can use whatever you want, like we use 2 and 4, but again, that meant I had to multiply 2 times a fraction. I got a negative. You'll see when I use 0, 0, my math is super easy. If it's, first of all, if it's 0, 0, then y is just 0. Now I'm going to multiply negative 1/3 times 0. So what's going to happen to that? Kayla, what's 0 times anything? So this just goes to 0. So my math is that. That's a lot easier than having 2/3 or 4/3 or 1/3 or whatever it is you might have sometimes. So I would personally always use 0, 0 just because it makes my math easier. And then if 0, 0 works, that's the side you shade. Don't always shade the side where 0, 0 is. Sometimes kids just shade 0, 0 every time. You have to plug it in and see if it works. And if it works, then you shade it. So in this case, is 0 less than or equal to 1? That's a true or false thing, by the way. Is it true that 0 is less than or equal to 1? Well, yeah, it's less than 1, so it is true. Which is, we better be, because we already said this was the side we should shade. And you could test any point in that shaded region and it would work. You could test any point not in the shaded region and it won't work. All right, so go ahead.
If it's not, then you should.
Yeah, if it's not, you shade the other
I'm kind
side.
of confused because 0, 0 is like in the middle of the graph. It's not on.
It's
one
relative
side.
to where the line is. Remember, this graph, these are imaginary. These are imaginary numbers, imaginary lines. The only line is this line. 0, 0 is below that line.
Oh.
So if 0, 0 works, you shade below the line, the red line. If 0, 0 doesn't work, you shade above the red line.
Oh, because I was talking about the other lines.
Yeah, no, those are imaginary lines where the axis is an now remember, I'll never call an axis a line. I'll call it the axis. So just keep that in mind. Axis is an imaginary thing. We are only worried about the line. We just use the axis to know where to put points. All right, so go ahead. You do not have to do number 3 where it says x is whatever and then some number. So do 1, 4, 5, and 6. So just 4 of them. That's all you gotta do. We're not gonna, I mean, if you want to try the back page, it's the same thing. It's just, you're gonna use the standard form method to create the first 2 points. And then after that, it's the same exact stuff.
So what number?
Oh, do you have a cup? Yes. 4,
4,
5,
5,
Oh, let me look.
1, 4, 5, 6.
I do.
Yes.
Actually, I have a couple.
So.
Now go next up here.
Why don't you just, since you do this all the time, bring this back and we'll
What?
You do this all the time. Or you need to bring a water bottle in or something. Just an old empty water bottle.
I mean,
They're going to restroom after burning after.
Yeah, would you, Brandon, if you?
I was about to go, but.
Oh, just,
It's fine.
I totally forgot. I thought you had already gone, actually. Tell them there's an emergency or you're looking for a pass or something. They don't check it.
Alright.
I saw one, I was out there the other day, they're like 50 kids wandering around. Never just gave up. Never's like, yeah, I can't, there's nothing I can do. A bus is coming, like you said. And nobody went to class, they just were hanging out instead of going to class.
Ooh, number 3's little.
3 you don't have to do, I said.
Oh.
Yeah, 3 is, you can do it, I mean, it's possible to do it, but I'm not worried about those weird situations. There's the whole problem, by the way. So if you don't know what to do, like if you're really struggling, you should at least be able to pull out the slope and the y-intercept from every problem. Except for 3, you don't have to do 3. So you can write M and B and pull out the slope and the y-intercept if you're struggling. So that when I get to you, we can work from there and I don't have to wait for you to do that. Let's see. Oh, let me stop the recording real quick, since this is just dead air.
We do 4, 5.
Yeah, 1, 4, 5, and 6. Good.